Hi everyone. For this video, I'm going to focus on how this formula is derived. Now I'm going to start from the very basics of graph to show you that there is nothing difficult about this formula. It all goes back to the very basic of the idea of gradient. Now in order to illustrate my point, I'm going to use the length of a mercury thread as an example. Again, let's go back to the very basic. Now, first of all, we have learned that the property of material can be used to measure temperature if it varies continuously and linearly with temperature. So in this case, this property we're going to use is actually the length of a mercury thread. In this specific example, we'll let L0 be the length of mercury thread at 0 degrees Celsius, L100 be the length of the mercury thread at 100 degrees Celsius, and L theta be the length of mercury thread at an unknown temperature theta. Now let us all establish this first. So once we get it, next we're going to go back to the graphical approach. As mentioned earlier, the very basic. Now what I have here is a graph of length against temperature. Since at length L0 the temperature is 0 degrees, we mark out this point L0 0 degrees Celsius and the length 100 at 100 degrees Celsius. So we already have these two coordinates. Never mind the unknown temperature yet. Since we have these two coordinates, and recall earlier on the property, which is the length of mercury thread, varies continuously and linearly with temperature. What does the word linear remind you of? So when we talk about linear, we think of y equals mx plus c, which is such a graph. Right, it's a straight line graph, okay, and it does not necessarily pass through the origin. That's why it's linear. So having known that, since the length varies linearly with temperature, we can just draw a straight line from the 0 L0 coordinate to the 100 L100 coordinate. And then next, we identify L0, L theta at an unknown temperature theta, somewhere along the line. So since length varies linearly with temperature, these three coordinates will form a straight line. And let us keep things as simple as we can. We label these 3 points A, C, and B. Again, recall, I say we go back to the very basics. So we go back to the idea of gradient. We're going to let gradient AC equals gradient AB. They can be equal because they lie along the same straight line. And from here, we're going to form the equation very much like what you learned in maths, y2 minus y1 over x2 minus x1. So for the gradient AC, we have L theta minus L naught over theta minus 0. And the gradient AB will be L 100 minus L naught over 100 minus 0. Now, once we form this equation, the rest is pure mathematics. We just manipulate it. And then after some manipulation, we arrive at this formula. So basically, it all boils down to a linear relationship and a graphical approach using the idea of gradient to derive this formula. So both approaches are acceptable in your exams, so not to worry.